Hi, my name is Sohail, and I started this channel to talk about software-defined networkings and network programmabilities. Uh, it's very important for a network engineer to know how to program networks. And one of the main scripting language or programming language that has been uh, necessary for a network engineer is Python. The challenge that I had as a network engineer was I would start a course online, would go through it for a couple of weeks, and after a while, I would leave it. Basically, uh, I'm gonna start this challenge, which is basically go from the very beginning to the very end of a online course about Python, and as a way to commit myself to do that is I have to repeat those lessons in this channel. So the source that I'm going to use is a free open source website. It's called Python for Everybody. I will put the link in the description. It has some get started, which talks about how to install the Python, and it has, I believe, 17 chapters, and of course an assignment page. So as I mentioned, I'm going to go through all of this, and I'm going to present the slides from these websites, and as a way to commit myself to this challenge. So without further ado, let's start with the first lesson, which is why programming, why to program, basically. So the idea is that computers are machines that they are not very smart. They need they know what they know how to do stuff, but we as a programmer or as a network engineer, we have to tell them what to do, and that's basically the reason that we need the programmability of a machine. Basically, again, so here is like talking about the application, the app that we have is way of communicating to the hardware that we have in our mobile devices, and to the programmers are basically the people who anticipate the needs of users and develop these applications. So as a user, we always have a different perspective of how stuff works, but when we go to the other side, we have to be conscious of some other stuff that as an end user we would never thought of. So we have to know how some of this stuff works at the back end. We have to make sure that we understand the way data flows, and basically we have to know to work with a set of tools that we have never worked before as a user. So this website is promoting, of course, the why to be a programmer. Of course, is for me as a network engineer, I think is a great tool to get some repetitive task done without error. When I start to do a repetitive task, after a while I get tired and I will become prone to mistakes. But if I can write a script to do that script can be run multiple times without any error, and I can use that script and give it to someone else, or I can use someone else's script and use it for my task. And that's basically what we need to learn here in terms of as a network engineer, in terms of like learning how to program machines in SDN. So this is again a slide talking about how user computer data information networks are connected. Basically, as a user, we have a different perspective, and users basically work with those applications that has been already built. But what we are trying to do here is to try to build those applications for the user right now. Not as complicated as they are, maybe a bit simpler, but at least we start doing to move towards that direction. So basically, what is the code software program? So the code is a sequence of stored instruction, and basically it's a piece of information or instruction that gives machines a kind of like a brain idea, so they cannot think. So that's what we are trying to do. We are trying to program them to think and react to a certain situation or do a certain task. And I've never been a developer, but I think as any form of craft, as you progress into it, you can look at it as art, of course. I can look at the network engineering as art, and I'm sure every craft has this perspective. If you become more knowledgeable and experienced, you will do your job as an artist than an engineer. At least that's how I believe. Anyway, so basically, programs for human. If we have this couple of in this paragraph, one of the things that we might not be able to pick up very quickly is the typos, but a computer can be programmed and to, for example, identify that this were a typo here. It's hand, not ham, and it's hip, not hit. Just an example. Another thing is, for example, if we get thrown at the text or paragraph, and we want to know how many words are in that paragraph, or how many words, or the number of words in that program, how many of those exist, basically. It's again complicated. It's not complicated, it's time consuming for the human being, but we can of course write the code to do that much faster for us. So this is actually the piece of code that we're going to talk about later about, and the way it works is it will count the number of words in a paragraph, and it will print basically the word that has been used the most. So talking about the hardware architecture, I believe the people, if you watch this video, you already know about it. As a network engineer, you probably have a background of how a computer works. There are some links here about, this is a Raspberry Pi, of course. I think most of us worked with it before. But the generic, traditional computers, basically, we have a CPU here, which talks directly to the main memory. We have a secondary memory, and we have our input and output devices. So what we are doing here basically is main memory, of course, has a higher speed, talks directly to the CPU. CPU is the one that basically asks us what's going to be the next task. Our program is going to be saved in the secondary memory, because you probably know if the secondary memory lose power, the data will stay there, unlike the main memory, which will lose its information by loss of power. So basically, we save our program in the secondary memory. When we run it, it will move to the main memory and it will interact with the CPU, and we can again save it back to the secondary memory. So again, some definition. We have central processing unit, which is basically the CPU is always asking what I'm going to do, what's going to be the next. We have input devices, keyboard, mouse, touch screen. We have output devices, which are screen, speakers, printer, or DVD burner. I don't know. It's a bit old-fashioned here, but the main memory, of course, is, as we discussed, is also known as RAM. Is super quick compared to the secondary memory, but it will lose the its information if it loses the power. The secondary memory, slower, but permanent storage, and permanent, of course, compared to the main memory. It doesn't lose information if it loses power, and the main form of it, as you know, they are disk drive or memory stick. Again, this slide talks about, this is kind of like where the programmer stays. So when the program runs from memory, from the secondary memory, and loads, it will come to the main memory, and that's the place that all the interaction with the CPU happens, and that's the place that, as a programmer, we have to be conscious about. That's the place that the programmer will work, and that's the place that the magic happens, basically. So one more thing is, if we have a language, for example, Python is relatively a high-level language, which means that it's closer to the way human speaks. But as it goes to the main memory, it has to be converted to the language that is understandable by machine, and it's called machine language. So we don't need to be concerned about that conversion. That conversion happens at the layer that we don't need to know, unless we want to dive deep into the programming world. But basically, that's what we are using Python, because it's more closer to our natural speaking language. So we're talking, this is a slide about, of course, what happens to the CPU, because it has a lot of interaction with memory. If we leave the cooling devices from it, it will get burned. Of course, it gets hot, it will get very hot, and it will eventually burn up. So this is apparently a link to an experiment that somebody did. Basically, while a computer was running, they removed the cooling device, and the CPU got burned. The hard drive, of course, there is another hard drive video that I think somebody started to open a hard drive while it was working. As far as I know, inside the hard drive is a vacuum, and you should not remove it, at least while it's working. But again, that's just FYI. If you are interested, just go watch this video. So we're gonna more talk about Python as a language. So it's funny, when the Dr. Chuck, the creator of this program, talks about it, he brings up the example of Harry Potter, and I can't pronounce it. Parseltongue is the language of snakes, apparently. And basically, Python is originated. Python is a snake, of course, but the way that the Dr. Chalk was talking about it is a funny story. It talks about how it just links a Harry Potter story to Python, and I recommend go there and watch it yourself. So Python was created by Guido van Rossum, and if you can speak Python, you're also known as a Pythonista. Just some fun fact here. The way Python works is it has a structure for the language. So we have to know that language and we have to know that structure. And if we don't speak that language properly and we don't type that language properly, we always get a syntax error. The way that Dr. Chalk talks about it is kind of like he used to get very frustrated when he sees a syntax error, but the syntax error is kind of a way of computer that says that I don't understand you, and basically what he's saying is that don't get this syntax error very personally, and we just need to learn the Python language so we can talk to the computer. It's much easier, of course, to learn the Python language than for computer to learn the English language. So, when you install Python, if you go to the command line, you see this tree chevron. That is basically, that's the prompt. That means that Python is ready to take your command and your information. So basically, that's way of Python showing on the command line that I'm ready to take your information. So one of the simple things that we can do over there is doing a simple assignment task, which is x equal 1. In that case, 1 is stored on the x, and the next line is to print it. And here we add another 1 to the existing value of x, and the next line we will ask to print it again. So 1 will change to 2, and exit with the parentheses will take you out of this command line environment. So basically, the way that we structure the language, or the way that we structure how we can write stuff in Python is we have a couple of ways. The first is vocabulary or words, which are variable and reserved words that we're going to talk about it in chapter 2. By the way, this material was taken from the same Dr. Chalk. He has a book called Python for Everybody, and the slides here correspond to the chapters in the book. So the first one was the vocabulary or words. The second one was the sentence structure, talking about the valid syntax patterns. That's going to be discussed in chapter 3 to 5. And we're going to have story structure, which is basically putting all those pieces together and creating a program for a specific purpose. So vocabulary, words, sentence structures, and story structure. So again, going back to this code that, to be honest, I don't completely understand, but I know what it does is it will find the most used word in a paragraph, and for example in this it will take a file. For example, in this example, it took the words.txt, and the output of it is the word. I'm sorry, the how do you say, not the word, but it is the word. I'm sorry, the word to has been repeated for 16 times. So that's the task of this piece of code. And this is the story basically. If you're going back, is kind of connecting a couple of sentence and words and building a story to accomplish a certain task. Okay, so going forward, we have a couple of reserved words, meaning that these are, we cannot use them as any other container or any other different task. We cannot assign them any other task. They are reserved. Basically, we don't have access, and of course we get to know all of them by end of this course. So going back to that tree type of structure, I believe we're gonna only talk about two of them. So we have the sentences or lines, which is the first one is just the assignment statement. We just assign 2 to letter X, and the second line we have assignment with expression, which means that we add 2 to the previous assignment. The third one is a print statement that will just print the content of X. So we have variable, operator, constant, and function, and we're going to talk about all of that in the later chapters. Talking about the paragraph, so we have the interactive Python, which is good for experiments and programs for 3 to 4 lines. That's basically that command line with 3 chevron. That's the interactive Python of it, basically, and that's the scripting part of it. Most of the programs are much longer, and that's why we need a different environment rather than that command line. And if we write a piece of script, we always save it with the .py, and the suffix will specify that this is a Python file. So in the interactive way, as discussed, is the same as that command line. We have the 3 chevron, and we basically type directly to the Python one line by one line, and we get our response back also. But if we do it as a script, we enter a sequences of the statements or lines, and we usually use a text editor and then tell Python to execute those sequences for us. So here we talk about the program steps or program flow. So we usually have a sequence, which means the specific order that we run the instructions, and it's like a recipe, of course. So we have to do a certain task in a certain order to be able to get the result that we want. Some of the steps are conditional. That means that, okay, if you have this condition, if you fall under this condition, then this will happen. Some of these steps are needed to be repeated, and computers are of course very good at this. They are very good at doing repetitive tasks that might be tiring for human. And basically the last sentence is saying that sometimes we store a set of steps to be used over and over as needed several places throughout the program. So what we can do is that's basically the definition of function. So you can write a piece of code that will always do a specific task, and you can call that piece of code throughout your program to do a certain task. So in the sequential steps, basically it's quite simple. Here we assign 2 to letter X, we print X, and we add 2 to the content of X, and we print it again. So that's very sequential. We just follow this sequence. We don't move to another part, or we just follow this sequence. In conditional step, basically example is, for example, we assign 5 to X, and here we check if X is less than 5, which is in this in this situation, we will have an indented line, and we start the commands here, and in this case we are going to type smaller. If the X is greater than 20, we're gonna print bigger, and after this indented section has been done, we come back to the print, which means that the print is gonna run eventually. So basically the output of this this code would be smaller, and because this doesn't fall under here, it will pass to here and it will print finish. So we're talking about the repeated steps. In this case, we have a loop basically that happens for a certain number of times. We assign 5 to letter N, and we say that as long as N is greater than 0, do this sequence, and the sequence is print N and deduct 1 from N and go back and do that again. So the output, and I'm sorry, after this is done, after we get out of the while loop, we will print blast off. So the output of this would be number 5, 4, 3, 2, 1, and when we deduct 1 from 1, we get 0, and when we come back here, this condition is not true, so 0 is not greater than 0, so we will get off the while loop and we will print this blast off. So that would be the output of this piece of code. So going back to that example of counting the most repeated word in the text, we have sequential codes here. We have repeating like a 4 sentence, and here we have like a 4 within a 4, so it's a nested 4. Again, 2 sequential codes, another 4, another repeated, and a conditional, an if statement. And finally, after we get out of the if and we get out of the 4, we will have a sequential print command. So that's another breakdown of that specific program. And I should have moved forward with the description. So basically, this is the story, this is the sequence, this is the repetition, and this is the condition. So basically, this was a review of the chapter 1 of the Python for Everyone, and you're gonna learn, of course, more about the Python. So I'm just gonna leave the acknowledgements page again. This is an open source material created by Dr. Chuck, and I'm just gonna leave it here, and thank you for listening to this program.